In this video, we are going to discuss about the weird story of how the computer mouse was invented. Before we get to the glorious, clicking little buddy that sits on your desk, let's rewind the clock. Imagine a world without it. It's a dark, strange place, my friends. Computers back then were giant, room-sized behemoths. They weren't friendly. They didn't have colorful screens or little icons you could click on. Interacting with one was like trying to have a conversation by feeding it coded messages on strips of paper. You had to be a super specialized scientist or engineer just to get one to do basic math. It was a slow, painful process that required immense patience. It demanded a deep understanding of complex programming languages. Your main tools for talking to these digital giants were things like keyboards, punch cards, teletype machines. Think about that for a second. A punch card is literally a piece of stiff paper with holes in it. You would spend hours, sometimes days, punching out precise patterns of holes to represent your instructions. Then you'd feed this stack of cards into the machine. If you made a single mistake, one hole in the wrong spot, your entire program would fail. There was no undo button. There was no dragging and dropping. There was just you, a stack of paper, and a machine that hummed with intimidating power, waiting for you to get it exactly right. This wasn't a system built for creativity or exploration. It was rigid, unforgiving, and incredibly inefficient for anything beyond number crunching. The idea of personal computing, something you or I could do at home, was pure science fiction. Computers were for serious business, calculating missile trajectories, running census data, managing massive corporate payrolls. They were tools for institutions, not for individuals. The user interface was, to put it mildly, hostile. It was a barrier, a wall that kept ordinary people away from the incredible potential that these machines held. This was the problem that needed a brilliant out-of-the-box solution. So how do you bridge that gap? How do you turn a cold, calculating machine into a partner for human thought? You needed a way to reach into the screen and interact with information directly. You needed a way to point, to select, to move things around as easily as you move objects on your workshop table. Enter our hero, Douglas Engelbart. Working at the Stanford Research Institute in the early 1960s, this guy was a visionary, a thinker who was light years ahead of his time. He wasn't just thinking about making computers faster, he was obsessed with augmenting human intellect. He believed computers could be tools to help us solve the world's biggest problems, but only if we could interact with them in a more natural, intuitive way. He assembled a team for his Augmentation Research Center. He set them a challenge: find the best way to point at things on a screen. This was a radical idea when most computers didn't even have screens as we know them today. The team tested everything they could think of. They tried light pens, they experimented with joysticks, they tried trackballs, they even built a strange device you controlled with your knee. They were building and breaking things, trying every wild idea to see what stuck. It was pure, hands-on research and development. In 1964, Engelbart sketched out an idea for a device that would roll on a surface, its movement tracked by two perpendicular wheels. He handed the sketch to his lead engineer, Bill English. English got to work, carving the first ever model out of a simple block of wood. What English built was, well, it was a little weird. It was a small, unassuming wooden box, just big enough to fit in the palm of a hand. On the bottom, it had two metal wheels, one oriented horizontally and one vertically. As you moved the box across a tabletop, the wheels would turn and track the motion along the X and Y axis. A single red button sat on top, and a long cord snaked out of the back, connecting it to the computer. It looked so much like a little creature with a tail that someone on the team, no one is quite sure who, nicknamed it a mouse. The name was just too perfect, and it stuck immediately. This humble wooden box was the very first computer mouse. It was patented in 1967, not as a mouse, but as an XY position indicator for a display system. It was a simple, elegant solution to a complex problem, but the world wasn't quite ready for it. Engelbart and his team famously demonstrated the mouse, along with video conferencing, hypertext, and windowed computing, in a 1968 presentation that would later be called the mother of all demos. The demo showcased the mouse. It showed video conferencing, it showed hypertext, it showed windowed computing. It was a stunning glimpse into the future of computing, but it would take years for the rest of the world to catch up to Engelbart's incredible vision. After its debut, the mouse didn't exactly take the world by storm. It was a brilliant invention without a home, Most computers still lacked the graphical interfaces that would make a mouse useful, so for a while it remained a curious piece of lab equipment, a solution waiting for a problem. But the idea was too good to die. Researchers at Xerox's Palo Alto Research Center saw the potential in Engelbart's work. They were developing the Xerox Alto, one of the very first personal computers with a graphical user interface, icons, windows, menus. The Alto needed a pointing device and the mouse was the perfect fit. The engineers at Xerox PARC took Engelbart's core concept and started iterating on it. This is where we see the mouse start to evolve. The original two-wheel design could be a little clunky, so they came up with a new mechanism, the ball mouse. Instead of two external wheels, they placed a heavy rolling ball inside the mouse's housing. As you moved the mouse, the ball would spin. Two small rollers inside would press against it, tracking its X motion, tracking its Y motion. This design was smoother, more reliable, and could work on more surfaces. It became the dominant mouse technology for the next 2 decades. This was also the era of experimentation with buttons. Engelbart's original had one. The Xerox PARC mice famously had 3. Why 3? The idea was that each button could have a distinct function, giving the user more power and flexibility without having to resort to the keyboard. This created a long-standing debate in the tech world. Some designers swore by the simplicity of a single button, believing it was more intuitive for new users. Others argued for the efficiency of multiple buttons for power users. This button war would continue for years, a classic battle between simplicity and functionality that defined early computer design. One of the most surprising facts from this period is just how much these early mice cost. The mouse for the Xerox Alto system in the 1970s cost around $300 to manufacture. That's over $2,000 in today's money. They were complex hand-assembled pieces of hardware. It wasn't until companies like Apple and Microsoft started mass producing them for the consumer market in the 1980s that the price dropped dramatically. A young Steve Jobs famously visited Xerox PARC, saw the GUI and the mouse, and immediately knew it was the future. He licensed the technology and tasked his team with building a version that could be made for about $15. The arrival of the mouse on the consumer market was nothing short of a seismic shift. When Apple launched the Lisa in 1983 and then more famously the Macintosh in 1984, they didn't just sell a computer, they sold a whole new way of interacting with one. The Macintosh came bundled with a mouse, and its operating system was designed from the ground up to be used with it. Suddenly you didn't need to memorize arcane commands like C:\\\, greater than delstar.txt. You could just use the mouse to point at a file's icon, drag it to a little picture of a trash can, and let go. It was revolutionary. This new point-and-click interface, powered by the mouse, democratized computing. It lowered the barrier to entry so drastically that people who had never considered using a computer before could now sit down and start exploring. Children, artists, writers, small business owners could use these machines without needing a degree in computer science. The mouse transformed the computer from a tool for specialists into an appliance for everyone. It made the digital world tangible. You could directly manipulate things on the screen, opening up new possibilities for creativity and productivity. Digital painting programs, desktop publishing software. The mouse also made computers fun. It was the key that unlocked the world of computer games. Early games had been text-based or controlled with clunky keyboard commands. The mouse allowed for fast, fluid, intuitive interaction. Games like Myst became immersive puzzles where you pointed and clicked to explore a mysterious world. Strategy games like Dune 2 let you command entire armies by selecting units with a click and directing them with another. And of course, there was the simple, profound satisfaction of a game like Solitaire, Minesweeper, which came bundled with Microsoft Windows and taught millions of people how to click, double-click, drag. It's hard to overstate how deeply the mouse changed our relationship with technology. It introduced a new physical language for interacting with digital information. Clicking, double-clicking, dragging and dropping are now so ingrained in our culture that we don't even think about them. They are fundamental actions, as basic as turning a page in a book. The mouse was the bridge between the human world and the digital frontier. It took an abstract concept, a cursor on a screen, and connected it directly to the motion of your hand, making the whole experience feel personal, intuitive, powerful. From its humble beginnings as a block of wood, the mouse has had an incredible journey. What started as a quirky experiment in a research lab became the standard issue tool for navigating the digital age. For decades, it was the undisputed king of computer input. Engelbart's invention, once a niche device, was now on hundreds of millions of desks around the world. The evolution continued with the scroll wheel in the mid 90s, a simple but profound change to how we browse. Then came the optical mouse. It replaced the mechanical ball with a tiny camera. More precise, more reliable, the mouse's success paved the way for touch-based interfaces. The core idea behind a touchscreen or trackpad is the same as the mouse's: direct manipulation. It's using a natural physical gesture to interact with digital elements. When you swipe through photos on your smartphone or pinch to zoom on a tablet, you're using the direct descendant of Engelbart's philosophy. He didn't just invent a device, he invented a new paradigm for human-computer interaction, one that valued intuition and directness over memorization and complexity. His wooden box was the first step on a path that led to the iPhone. Today, in 2025, the landscape is more varied. Touch screens, hypersensitive trackpads, voice commands, gesture controls. Some predicted the mouse's death for years, yet it endures for tasks that require precision and speed: graphic design, video editing, competitive gaming, complex spreadsheets. It offers a level of control a finger often can't match. The mouse has proven remarkably resilient and adaptable, holding its own in a world it helped create. Next time you rest your hand on that familiar plastic shell, pause and appreciate its bizarre and brilliant history. Think of Douglas Engelbart and his dream of augmenting human intellect. Think of Bill English carving that first prototype out of wood. Think of that simple, strange idea: a box, wheels, a tail, rewiring our world. It turned intimidating machines into friendly collaborators. It opened the digital realm to all of us. And it proved the most powerful inventions often feel simple and natural. We can't imagine life without them. If you liked it, tap that like and hit subscribe so you don't miss what's next.